please note they don't ask you to do anything except what, Ashley? Practice A, B, and C. They just ask you to,
Find excluded values.
which means what, Grace? Find the excluded values means what? Notice there's no simplifying there, there's no word solve there, it just says find the excluded values. If you're excluded, is that usually good or bad?
Bad.
Okay, so we're looking for the bad values here, which means what? Nicole Grayer?
H.
Huh?
H.
H?
The letters.
H? H means nothing. What do it mean H? It's like saying T. T.
Iced tea.
Charlie.
Zero.
Caroline, pay attention, I might need you here. Charlie.
The numbers and letters that are left out.
So virtually in letter A would be all letters of the alphabet but H. Is that what you're telling me, Charlie?
Zero.
Charles.
Charles.
Oh.
Caroline.
The numbers or the letters that can't equal 0 put them on 1.
Right. When it says state the excluded values, when you have 9 over 4h, they are 4h. 9 over 4h, they are just saying, they're just asking, what cannot you have down here? What can't this be? This cannot be because of commandment number 1 over there on the rules there. Yeah, you can't put 0 in for h because 4 times 0 is 0, and you can't have it. So h cannot equal 0. That would be the answer to the first one. Let's go right to the big finish here. What about letter C? G minus 5 over 3g, g minus 5 over 3g minus 15. What would be the excluded value? Don't tell me 0, because it could be 0, because 3 times 0 is 0, 0 minus 15, you get a minus 15 on the bottom. What cannot you have there, Gabe? 5. Well, how do you know it's 5? What, Gabe, if I'm not smart enough to think that far in my head, what could I do? You take this bottom, make an equation out of it. You want to know when 3g minus 15 would be equal to 0 and solve it. Because whatever you get for g there means it's what you can't have because you can't get 0 there. So you would add 15, you would add 15, you divide by 3, you divide by 3. G cannot be 5. Okay, 3 times 5 is 15, 15 minus 15 would give you 0.
You don't have to do anything with the top.
No, not when they state excluded values. There's nothing you can do. Now, with that being said, Taylor Pavio, looking at letters D through G, it says simplify and identify excluded values. So if you look at letter E where it has D plus 1 over D, D plus 1 over D, let's see. Simplifying that, I would get, Mackenzie, D1.
D1.
We're all going D1?
Yes.
D1.
D1. Double D1.
Repeat just once.
Repeat after me. I am a failure. Once again, for the umpteenth thousandth time, for those of you that said 1, you cannot do that.
I didn't say 1.
When it is an addition problem, you cannot just take pieces of an adding thing and say, oh, these are both D's, so I'm going to cross them both off. For the same reason, here's your example of that. If you have 3 plus 1 over 3, you know the answer to that is 4/3 because 3 plus 1, this is like a grouping symbol. 3 plus 1 is 4. You can't just go, oh, there's 2 3's there, and my answer is 1. They have to be factors. In other words, it would have to be, if it was D times 1 or D times D plus 1 or something like that, if those two were factors in multiplication, yes, you can cross off. But you can't just pull apart a piece of an addition problem. Letter E cannot be factored any more than it is. They threw that in there. Now, letter F. 3z squared minus, fortunately we've got like a zillion of these to do. 6z over 5z minus 10. 6z over 5z minus 10. So, you know what the problem is, that I should not be using that, I should use a brush, and then we're gonna go down to the bottom. What does that read me then again? 3z squared minus
60 over
6z
5z minus 10.
over 5z
Minus 10.
Minus 10.
Okay. Again, as that stands right there, you cannot do any crossing off because there's no factors. Okay, when you've got two different terms, you're gonna have to get something in parentheses times something in parentheses, and hopefully the parentheses match up. So you have to look at it and you go, okay, I need to make this some sort of a multiplication problem, I need to factor this out, that's why we study factoring. What can I take out of these two? A 3 and a z. They both have 3 and a z. If I take a 3 and a z out, I'm left with a z minus 2. And here is where the book helps you out, because I'm sure it works out. In order to get anything to cross off with something on the bottom, you need to get either a 3 or a z or a z minus 2. You can't, this has to be factored as one big group if you're cross canceling. I have to get a z minus 2 for that to cross off. Well, let's look. On the bottom, I take a 5 out and I'm left with a z minus 2. And whoa, yes is right. Z minus 2 will cross off with the whole term z minus 2.
15.
What are you left with? 3z, the 5 and the 3 don't cross off. You're left with that. Which, by the way, since we're talking about this, Taylor, what is my coefficient in this problem?
5.
It is not 5.
It's 3/5.
3/5.
No.
Z. 3/5 Z.
No. Coefficient is the number in front, which is 3/5.
3/5.
The variable is z.
The factor is 3/5.
The
Is
factors
3
are
and
3/5
Z.
times z.
It's 5.
What would be the excluded value here?
I'm really confused.
No.
0.
2, because 2
2.
minus 2
Oh,
would
yeah,
give you
2.
0, or 10 minus 2. Wow, I think we've made some serious
Oh,
progress.
We have charted some.
I don't think so.
And then look at letter I.
Wait, how many people got that early test?
I don't know. I'll get back
Our
to
tests
you.
are online. Yeah.
They are online.
Yeah, I'm really upset with my grades. I already know that.
End of the fourth. Let's just move on from there, shall we? 3m to the negative 2 or n to the negative 4. Here is what takes a little bit of brain power here. I don't know.
Plus.
Alright, if you look at this in the direction, say, to simplify. Right now, what would you have to do? The only way to simplify that is if you could actually add them together. How do I know if I can add them together?
Put the fraction into a thing.
Alex Vollmer, I'll entertain something here.
You have to put the n negative 4 into the.
Okay.
Move
Alright.
that.
Alex has a good point, and I think it's a valid one. Generally speaking, in order for you to tell if these are actually like terms, you gotta be all consistent, which means bring this up to the top so you can see if it's an m negative 2 n to the 4th. So let's look. 6m negative 2 n to the 4th plus 3m negative 2. I'm moving this to the top, making it n to the positive 4th. Again, this thing is kind of going goofy. As long as these are the same letters to the same exponents, these are like terms, which means you can combine them, which if you have 6 of them and then 3 more, you end up with
That's 2.
9.
9.
6 and 3 is 9 every time.
Oh.
M to the negative 4th, yes?
Yes.
No.
Yes.
No,
No.
no, it's n to the negative 7.
Right. Remember, people, look up here, Grayer, you with me? What's over there? Is Morgan yelling, distracting everybody?
Yeah, what? Yeah.
When you add terms together, m to the negative 2 plus another m to the negative 2 doesn't make up m to the negative 4ths. That's when you multiply. It still stays the same. M to the negative 2 over n to the 4th. Now that's still not your answer, mostly because it's not in its simplified form, which means you still need to take and put that m back to the bottom to make it a positive exponent. Your answer is 9 n to the positive 4th over m squared. And again, Taylor, the review on this is this. Here's the difference. If I have 3x plus 3x, that is
9x.
3 plus 3 is,
Oh, 6x.
if I have 3x times 3x,
9x.
that's
Squared.
9x squared.
Squared.
Adding stays the same, multiplying. Perfect. We are moving forward. I love that. All right. Look at lesson 52. I am not going to go over that because that is simply slope of a line, and you've done so much on slope.
This is like,
That's my go-to.
we learned that like in 7th grade.
We will take some notes on this next section, 53. Take out a blank piece of paper.
I remember these.
Write this down. I just did this with 7th grade, so I know you did it last year about this time of the year.
That's a year ago. Polynomials. It's like binomials, but poly. Wow. Is this one of our root words?
A polynomial, which you've been working with forever, is nothing more than either a monomial, which is a single term thing, or the sum or difference of monomials. And here's the example. I don't think you'll need much on this. 3x, that's a one-term thing. That's what we call a monomial. It doesn't have nomial. Okay. It's a one-term thing. It's one expression. Okay, it doesn't have any addition or subtraction signs. I could put a minus in front of it, it's still a monomial. Okay, a two-term thing would be something like x minus 3. Notice how there's an x and a minus 3. This little thing here, addition, subtraction signs that are not in parentheses separate terms. Two-term things we call, we've worked with these before, binomial. Three-term things, let's say x squared plus 2x minus 4 is a trinomial. Maybe you see the prefixes there. Mono, 1, bi, 2, tri, 3. Now remember, this has to be in its simplified form. So if they gave you a problem that was this, x plus 3x minus 8, and they asked you what type of polynomial that is, you can't just right away say that's a trinomial because you see 3. You have to simplify first. You look at this and you go, oh, I can put those two terms together. X plus 3x is 3x squared.
4x.
That's right, 4x minus 8, and that makes it a binomial.
Oh!
Okay.
The proverbial light bulb has gone off.
Binomial, binomial, trinomial, and then in addition to that, we have to talk about a degree of a polynomial.
Wait, I thought it was. What's a polynomial?
We'll answer that again later. In order to understand the degree, okay, you have to understand, in order to get the degree of a polynomial, you must understand the degree of a monomial first. Or it's monomial. Monomial, monomial, monomial. Okay, if you have something like 3x cubed y, the degree of a monomial, the degree is equal to the sum of the exponents, we did this by the way too, of the variables. I'll let you write that and let it sink in before. Zach, you got that down here? What's that? Oh, wait a second.
of the exponents
It's
of the variables.
Confusing, huh?
Wait, is that a 3 or a 4? X cubed to 4.
Morgan, have I got to that point yet?
Wait, isn't that
All of these will be covered shortly. I'm just making sure everybody, see Morgan, not everybody's as fast a writer as you.
Yeah, Morgan.
Not everyone
Let's
has
let them
read
all,
it. I
let's
couldn't
let
read it.
everybody get to the same point before we
Morgan.
start jumping on.
You're really hurting my feelings.
Yeah, Morgan.
My self-confidence is working.
The degree of a monomial is equal to the sum, which means you add the exponents only of the variables. Because if you look at this in the real world, this 3 could have a 1 as an exponent if you really wanted to, and this y could have a 1. But we don't count the constant exponents, you just add together the variable exponents. This thing is a 4th degree monomial, if that's what you were saying, which I think it was, Morgan, but
No, I was asking if it was X cubed.
She didn't know how you wrote it.
that looks like a 2 to you?
Yeah, well, no, now it doesn't. Actually, okay, never mind.
Kendall Howard.
Isn't 3x cubed y, isn't that a binomial?
That would be a monomial. Binomial has 2 terms, this has 2 variables, but they're all multiplied together. This is one whole group together, one expression. There has to be an addition or subtraction sign to get more than just a one-term thing. Huh? I don't know what that means, but if I could still write this like this, 3 times x to the 3rd times y, still a monomial. There has to be, Kendall, this would be a binomial. Notice how 3 separated by addition, subtraction signs. This is not multiplication, this is all addition. However many things you are adding or subtracting together is how many terms it has, which
Is that
makes
a
it.
trinomial?
This would be a trinomial.
Okay.
But then if you simplify it, it would be a final.
I can't simplify that. They're no like terms. Kyle,
Can you explain that all again?
I will, probably a dozen times. Taylor,
Okay,
I'm getting there. Just hold on.
so with the what?
See, Kyle, I have to explain this to Kyle because Kyle gave me the look like I was just brushing off his question. See, I'm gonna ask these 2 and see if theirs relates to yours so I can address all 3 at once. I'm not just blowing you off, Kyle.
Yeah, Kyle.
Taylor.
Yeah, Taylor.
Okay, so with the y and the little 1,
We don't write ones, they're just there.
so if there's the x and it's just the, what was it, a 3? It's just the 3. We know that there's supposed to be a 1 by the y, so we know that it's 4, correct?
Sure.
Or do we have to write the
You don't have
whole-
to write it. I just put it there so you can see that that's.
And it's not like, that's what if there's just an x and a y?
There's 2, so there's a 1 with a 1.
Okay.
Melas.
So could they be separated, not just by addition and subtraction, but could they be separated by like division and multiplication? Like 3 times
Oh, a
x.
division.
Don't!
Actually, I'm just.
That's a good question.
Oh, no, it's.
Are you asking,
Some of us aren't as fast as writers as you guys.
are you asking if that would be a,
Like, is that, how many terms is that?
well, that's 1 term.
Wouldn't that be a real like, has shut off?
No more, kid.
I don't know, I'm gonna have to say, if you ask me what the degree of this term is, I would have to say it's a 0, because if you actually add the exponents together, this would be a -1 plus a 1.
So a 0 means.
Yeah.
Haven't run across that.
Some proverbial light bulb.
Alright,
has gone
Kyle.
off.
Mine's
Yeah.
15 x, y, z. The degree of that, this is a single term, there's no addition subtraction stuff, it's a monomial.
4th degree. 3rd degree.
Third.
It's a 3rd because there's assumed 1s here.
Oh, I thought that was
Okay.
b squared.
So if you
What?
add,
Whatever the exponent is.
I know.
is it squared? 3.
No, I literally.
So you don't even like, you just like cross out the 15.
You just don't.
Wait, so how do you write degrees?
You rank
No,
the
like,
word
how do you write
degree.
degrees? equals.
Don't lose me now, because then I would have to assume to get you back on track, you have to do a lot of homework, which. Now, a degree of a polynomial, Kendall, a degree of something that has more than one term is equal to its highest degreed term. And that will make no sense to you. Please don't ask me what it means until after I explain it. Morgan, I'm gonna let people write this down. Please don't shout out the answers to whatever you think it is. The degree, we just looked at the degree of a monomial, a one-term thing. Now we have to know what is the degree of a polynomial, more than one term. It's equal to its highest degreed term.
I get that. Oh. Three. Is that together?
Your question, Kendall.
The thing that you did before, it was like 15x.
Y, Z, yes.
Would you cube that?
I don't know where a cube comes from. I would cube it. I don't know how you could cube it. There are no like letters there. Alright, so if you are asked to find the degree of a multi-termed phrase, whatever, what you must do is you need to look at each individual term and find its degree. This x cubed means this is a third degree. This x squared yz is a fourth degree. This has no degrees. The degree of the polynomial is equal to the highest of the degrees of any of the terms. So this is a fourth degree polynomial. You look at each term, what each degree is of each one, find the one that has the highest. You don't add them all together. Do not add them all together. You just find each one separately, and whatever the largest one is the largest one.
Oh my. No adding. I like the other one better. I like that way.
Plus one. What do you mean what way? There's no way.
Yeah, there is.
It's the same thing we've been doing. There's not a choice. This is not a choice of whether you like to do it this way or the way we did before.
This is the way you
It's
do
the
it.
same thing. Morgan, your question.
Okay, so when you write the answer, it's 4, but then how do you write it like on your
Just put a fourth degree.
Wait, so what was?
Fourth, write the word degree. Fourth degree.
Wait, so then how did you get to these a fourth degree?
Well, I didn't know if we still in a circle.
2 plus 1 makes us a fourth degree term.
Then what happened to the other degree?
You don't look at it because it's not the highest degree of term.
Oh!
Fourth makes us the kind of degree like the little circle.
Yeah, you can write
That's what I thought was.
Kendall.
I'm really confused how it's said it's fourth degree and then all three.
What's this number? What's this number? What's this number? Add them together? How is that
So it's
confusing?
just there, you don't have to add the first one.
What first one?
The cube.
This is a different term.
Oh.
You look at each term separately. Maybe if we do one or two more. Let's say you've got 3x to the
Not
third,
everybody's as smart as you
y
guys.
to the third minus 2.
I guess we just need to go to NCA.
Okay, you've got to look at how many terms do you see here? There are 3. How do I know? Because they're separated by subtraction signs or addition signs. So you have to look at the degree of each one of these separately. You don't put them all together. This has 3 plus 3, it's a 6th degree. This has a 1 plus a 1, it's a 2nd degree. And this has a 7, so it's a 7th
So 7th
degree.
degree wins.
So the
Yes,
biggest,
Taylor.
the biggest term,
Is the next one the least amount?
the smallest degree.
No. For the trinomial,
And
is it
last.
remember what's the least amount?
Please write this down. The standard form of a polynomial means that you write the terms in descending order of degrees. Once again, a lot of words. It's not really hard, but we will wait till everybody writes it down before we start ranting and raving about what it actually means.
I get it.
I get it. I get it already.
Do you get to that?
I do. Taylor, you should just be on that.
I know.
Boy.
And that, ladies and gentlemen, simply means this. When I read the answers, when the book gives an answer, it will give the answers in standard form, which means you start with the highest degree term and you order them going down to the smallest degree. So if this is a third degree, second degree, first degree, 0 degree. So when you put these down, it's just commonplace to say, I'm going to put the 5x cubed first,
Oh, so it's not.
followed by the 3x squared,
Oh.
and then the 6x,
Oh.
and then the 8. Simply, more or less, so that it's not as confusing, because when you've got 5 or 6 terms, okay, you want to be able to put them in order, so when I read them, you're not trying to see if you have that term.
So you don't just put like
Well, it usually
3,
asks us to
2,
put them in standard
1,
form.
0.
I don't know what that
Yes,
means, but,
Like the term, like the actual degrees of them, that you put like.
no, we're just writing these down. We're just
Okay,
Does it
so
always
you
have
want
to
to put like the third degree, then the second degree, then.
Standard operating procedure says yes, you should put, when you give answers, always put them in standard form. Morgan,
Well, what do you do with the subtraction?
it doesn't matter. I'm sorry, this should have been minus. Whatever signs in front of the number is what sign you take. Ava,
If you have two that are
that are the same, I guess you just pick whichever one looks to be your favorite. There are so many what ifs in this, you know. What if your hand
In
got
the
easy?
proverbial mind.
What?
Kendall,
Can you redo that bottom part?
can I redo it?
Redo it.
Which part?
I have the 3x squared plus 5 blah 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 down, but then how do
You need to put these, you need to again look at the degrees of the terms, Kendall. This is a second degree term, a third degree term, a first degree term, and a 0 degree term. You just need to put them in order of the highest degree to lowest, just for continuity. So at all, when I read the answer, I will put the 5x cubed first. In essence, is your answer wrong if it's not first? No, because it doesn't matter in addition, subtraction, the order, but just because that's the way I'll read the answers, it's less confusing for all involved. And then last but not least, adding and subtracting. Again, try not to lose focus with me. Adding and subtracting. Write down 2 example problems that will get us all the way verbally home. Write this problem down, negative 8x plus 4x squared minus x plus 1, all plus 3x cubed minus 2x plus 7.
Oh.
And then this one, 6x squared plus 4x plus 2 minus
Is that X plus
3x squared minus 2.
What are we doing here?
Minus 7x, sorry.
What are we combining with?
Hold on, again, don't ask questions
Oh,
now.
got it.
Minus 2. I will entertain all those questions later.
Wait, what does it say? X plus 2, and then is there a little square thing?
No, just plus 2. This was supposed to be my parentheses.
Can you read off,
6x squared plus 4x plus 2 minus 3x squared minus 7x minus 2.
They really got the layer.
Alright, listen carefully, children, and I know it's been a long, we've covered a lot of ground today, most of it unproductive, but. Okay. First thing, if it's addition, what throws people off are these parentheses. And in this first one here, these parentheses are completely and utterly worthless.
Worthless.
Okay? They're simply there for no real reason, because when you think about how we get rid of parentheses, you use the distributive property. And what's in front of this parenthesis but a plus sign, or if you like, think of it as a plus 1, because it's the same thing. And if you were to multiply all these by a plus, they just stay the same. Same thing here. The only reason that this parenthesis might do some good was if there was a negative out here, but there's not. It's a plus if there's no sign given. So when they have a parenthesis without a negative in front of it, these do not matter at all, and you can just add the like terms. Okay, the biggest term we have is this x cubed term. Is there any other x cubes? No, so you can't combine it with anything, you just end up with 3x cubed. And then here you have an x squared term. Are there any other x squared terms? No, so it just stays an x squared term. And then you've got some fun here, because here's a minus 8x and a minus 2x. Those are like terms, so you can put them together to get a minus 10x. And then you have a 1 and, oh, I'm sorry, did I write that down right? Is that right from the book?
Yeah.
Oh, I'm sorry. This one was supposed to be cubed. That's all right. Let's do minus 11x, because it is minus 8, minus 1, minus 2 is minus 11. And then you have a 1 and a 7, which is
Wait, how
8.
did we go from minus 10 to minus 12?
Well, because there's this other minus x here. Minus 8x, minus x, minus 2x.
That means
You
you
can still simplify.
You cannot simplify that anymore.
Oh, no.
What's the degree of this polynomial?
Three.
I said that's alright.
The
It's a
third degree.
polynomial.
Trinomial.
It's not a trinomial. There's 4 terms here. Now, this second one here, please. This is where the parentheses do matter. Charlie, work with me here. Okay. This is where they matter, not so much in the first one because there's no minus in front of it, so this all stays the same. These really don't matter. But this minus sign does. And you have to think about that as distributive property. This minus sign gets distributed out to all 3 of these, changing their sign. So when you get rid of the parentheses, this becomes a minus 3x squared, a positive 7x, and a positive 2, because this minus goes for all 3 of those terms. Once you do that, then you can look at this and combine like terms and do whatever has to happen there. You've got 6x squared minus 3x squared is a 3x squared. A 4x and a 7x is a 11x, and a 2 and a 2 is 4.
Wait, what is it? Minus 4?
Yes,
Minus
like that,
2?
right.
Minus 4x minus 2 up there?
And the degree
Plus
is
4x plus
the second
Degree
degree.
is the second degree.
Yeah,
And it's
confusion is overrated. As far as I.
Bios are
Because you
overrated.
need something to do.